All right, folks, in this video, we're going to talk about the difference between the two different kinds of breakage patterns, fracture and cleavage. Minerals can break in two different ways. They can either fracture irregularly, or they can cleave in a very regular and predictable way. This can be a little tricky to discern until you've had some practice doing it, but I've got the confidence you guys will be able to figure it out. So first, we're going to look at some minerals that have cleavage, and then look at how ones that have fracture are different from those. So when you're looking to tell if a mineral cleaves or has cleavage, you're looking for the kinds of shapes that you see in your geometry class, for instance. So like when I look at this mineral here, this looks like a very straight cut edge, okay? And so does this. And in fact, we can see that this surface here is really shiny and reflective. That's a pretty good indicator that this mineral breaks naturally along these flat surfaces, okay? And it's not shiny like metallic, it's also really smooth. So those are all natural breaks in this mineral. And if you look closely, you can see what looks like a bunch of little cutouts that follow a very specific pattern. Those are all natural breaking points in this mineral. And if you examine really closely, you can see them in a lot of different places where the mineral has started to break apart into smaller pieces. There's some really good ones here on this face. So when we see things like regular shapes and very straight edges and shiny, reflective, flat surfaces, that can often tell us that a mineral has cleavage. So this is one example of a mineral that has cleavage. Another one that has cleavage is this mineral halite here, or rock salt. Again, we can see that it's got really straight edges. This was not cut, this is naturally occurring. And we can see that the flat sides have a little bit of shine to them. So that's often that's again a good indicator that this mineral has cleavage. In fact, these two little tiny pieces that I have right here, these perfect cubes are pieces of halite that broke off of the larger piece, but these were not cut. This happens naturally. So anytime you see a shape that looks too perfect to be true, that's probably a really good indication that you're looking at a mineral that has cleavage instead of fracture. Another kind of mineral that has cleavage is this mica here. This is one solid piece of mica, but if you guys have looked at mica in class at all, you know that mica can peel away in these really thin sheets. It flakes, and that's the way that mica cleaves. But because we know how it's going to break apart, we know it's going to break apart in these sheets, almost like the pages of a book, and the rest of the surfaces are very flat and shiny, that tells us that this is a mineral that has cleavage. One more example of a mineral that has cleavage is galena. Now in this particular sample, it's a little harder to see, but if you look really closely, once the camera comes into focus, you can see that there are some regular corners here, and there are some 90-degree angles. This sample doesn't have as neat a cleavage as some of the other ones that we've seen, but if you look really close, again, you can see some perfectly straight lines in how this mineral broke apart, and that tells us that this is a mineral that cleaves instead of fracturing. Now, some of our minerals that fracture. When you look up close at them, there is absolutely no rhyme or reason to how they've broken apart. There's very few straight lines. There's very few perfectly flat or reflective surfaces. So even though this piece of quartz here has a little bit of reflective, none of it is flat surfaces, okay? So this breaks randomly. Same thing with this sulfur here. If I were to hit this with a hammer, I have no way of knowing how it would break apart. There's no flat surfaces, okay? And again, with these two minerals, there's no perfectly flat surfaces, and everything just kind of looks rough and jagged and bumpy. that tells us that this mineral has fracture, not cleavage. And same thing with this sample here. It's got a lot of really rough, bumpy edges, nothing really straight or regular. Doesn't look like anything we'd see in geometry. So that's how we know that this is a sample that has fracture. So we've got the things that fracture, where nothing looks regular, they all look kind of rough and bumpy, nothing really smooth and shiny. And then we've got our samples that have cleavage, where we see a lot of regular, predictable shapes and straight lines. And that's the difference between fracture and cleavage.